Okay, this video is going to cover Chapter 10, Lesson 3. It's day 2 of the notes. We're going to be writing equations of hyperbolas. So just like before, it's probably a good idea to go ahead and give yourself a visual. So I'm going to go ahead and put on my coordinate plane my given information. Notice they're telling me that these are the x-intercepts. So 1, 2, 3, 4, 1, 2, 3, 4. So my x-intercepts are going to be negative 4, 0 and positive 4, 0. I've also been given my focus point. So I've got one at negative 5, 0 and positive 5, 0. So those are my focus points. Remember, the focus and the vertices are always on the same axis. So right away I can see that my vertices are touching the x-axis. So this is going to tell me that the x squared is going to go first. It's always a subtraction sign. Go ahead and fix this. So it's going to be x squared. A squared is always under the first one, y squared, and then b squared, and it's always set equal to 1. So now what I need to do is figure out what a squared is and what b squared is. Now, remember, here in my graph, the center of my hyperbola is always going to be equidistant, or the middle of those two vertices. So this one has a center at 0, 0. And then my a value is always the distance that the vertex is from the center. So we can see that your a value is 4. So if a equals 4, then a squared equals 16. Now, I don't know anything about b. The way that I'm going to have to find b is I'm going to be using, or b squared, c squared equals a squared plus b squared. Now I can find the value of c. C is going to be the distance that the focus is from the center. And I can see that it's 5 spaces away. I could either do it on over there, or I could do it from over here. Either way, it's 5 spaces. So if c equals 5, then c squared equals 25. So let me go ahead and plug that into this formula. 25 equals 16 plus b squared. Subtract the 16. 25 minus 16 is 9. So b squared equals 9. I don't need to square root it, because remember, all we're doing is plugging it in. So final answer here is x squared over 16 minus y squared over 9 equals 1. And there's my first equation. I'm going to try another. It still has the center at 0, 0. Again, this time they gave me the vertices, and they also gave me an asymptote. So let me go ahead and graph the vertices. So my vertices are going to be at positive 6 and negative 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it's the order pair 0, 6 and 0, negative 6. Actually, these are vertices, so I'm going to do them in blue. Now, we can already see that my graph is going to touch the y-axis. So this tells me I'm going to be using this formula with the y squared first, then the x squared. Again, a squared is always under the first fraction, and b squared under the second fraction. Now, when the y squared is the first variable, when it touches the y-axis, I know my asymptote equation is going to be a over b. So if I know that this y equals plus and minus 1/2 x, 1/2, the 1 is a, and then the 2 is the b. Now, I already know that my A value is the distance from the center that the vertex is. So my A value is 6. So what I need to do is I'm going to take this proportion. I'm replacing A with 6. I don't know the B yet. So now I have a proportion I can solve. So I'm going to multiply 1 times B, 6 times 2. So I get B equals 12. So if B equals 12, then B squared equals 12 squared, which is 144. Now I have my A value, which was 6. So A squared is 36, and that's what I need to fill in, my A squared and my B squared. So final answer, y squared over 36 minus x squared over 144. And you're done. Let's try example 3. Again, let's give ourselves a visual. I have vertices at positive 3 and comma 0 and negative 3 comma 0. So I have a vertice right here and right here. I've also been given an order pair that's on the hyperbola. So 4, 5, 6, and then it's going to go up to 1. So this is on the graph. So you can see that your graph is going to go like this. So again, you can see that the two vertices are equidistant from that center, and the length or the distance from the center to the vertices, my A value is 3. Doesn't matter if I count it on this side, I still get the same answer. So A equals 3, so then A squared equals 9. Now, I also have an order pair. Remember, an order pair, this is x, this is y. So now I still need to find b squared, and I don't know anything about the focus, so I'm going to use the x and the y from the order pair. Now again, you can see that it's touching the x-axis, so this is the equation I'm going to be using. And now I'm going to plug in what I know. So I'm going to plug in this 6 up here for the x, and I'm going to plug in the 1 for the y. And then I also have my a squared that I can put here. So let's go ahead and plug it in. So 6 squared over 9 minus 1 squared over b squared, because I don't know anything about that. So let's go ahead and take care of these squares. So it's going to become 36 over 9 minus 1 over b squared equals 1. Now, I could solve this 2 ways, and let me show you the 2 ways I'm going to do it. First way is I'll go ahead and divide 36 by 9, get 4, move the 4 to the other side, negative 1 over b squared equals negative 3. And now I need to solve for b squared, so I could multiply both sides by b squared to get it out of the bottom of the fraction. And now I'm left with negative 1 equals negative 3b squared, divide by negative 3, and b squared equals 1/3. I don't need to square root it, because again, remember, you're looking for b squared. Now the other way y squared is first, your equation for your asymptote is a over b. So now what I'm going to do is, I know that this is what a over b is equal to. I could change it to a fraction. So a over b is equal to 5 over 1. Now, this time I don't know anything about a or b, so I'm going to have to work with this as an expression. I'm still going to solve this as a proportion. I'm going to multiply diagonally, and I get a equals 5b. So now what I'm going to do is take and work with my c squared equals a squared plus b squared. I know c squared, it's 13. And now my a is 5b, and I have to square that. So that's going to become 25b squared. It's because I have to square the 5 and the b. Now notice these are like terms, so I can add them. And now I'm going to solve for b squared by dividing by 26. I get b squared equals 13 over 26, which reduces to 1/2. Now that I have b squared and c squared, I'm going to do this formula one more time to get a squared. So again, c squared is 13. I don't know a squared, and I know b squared is 1/2. I'm going to go ahead and move the 1/2 to the other side. Now I'm going to make this have a common denominator, so I'm going to change the 13 into 26 over 2. So this ends up being 25 over 2 equals a squared. So now I need to plug it in to this formula. I'm replacing the b squared, and I'm replacing the a squared. So final answer is going to be y squared over 25 over 2 minus x squared over 1/2 equals 1. Now again, remember, be aware that this could be an answer on a standardized test, or even on the test that we're taking. Now, however, if they tell you do not leave a fraction in a fraction, we're going to take these denominators, these 2's, and move them to the top. So this becomes 2y squared over 25 minus 2x squared equals 1. And this would be the other acceptable answer. We're going to do 2 examples where the center is not at 0, 0. So again, let's give ourselves a visual. I'm graphing the 2 vertices, 1, 2, 3, 4, 1, 2, 3, 4, 5. I have a vertex right here at the order pair 4, 5, and then I have another one at 4, 1. Now, I need to find the center point. I can do that 2 ways. I can either take my 2 coordinates, do the midpoint formula, x1 plus x2 divide by 2, y1 plus y2 divide by 2, 8 over 2, 6 over 2. So this gives me the order pair 4, 3. That is going to be my center point. I could have also just counted and found the middle here. So you can see that from the center to this vertex, my a value is 2, and then the same thing here. So when we're doing this, we can either figure out where is the middle of these 2 blue dots, or we could have done the midpoint formula. Now the other piece of information that was given to me is the asymptote. Now again, you can also see that it's vertical, so the equation we're going to be using is going to be y minus k squared over a squared and x minus h squared over b squared equals 1. For our asymptote, when the y is the first letter, this is the equation for the asymptote. And again, remember, this is k, this is h. Now, notice my asymptote is not in point slope form. They've actually moved this y1 to the other side.